Hello students. In this session, we are going to discuss the questions based on ITF inverse trigonometry functions. Now, before we proceed, ITF has a lot of formulas. I hope you already know all of them. I hope you have learned all of them because you will need a lot of formulas when we go through the sums. So learn all the formulas, the domain and range table, and everything in detail. Now, students, before we proceed with the questions, there are a couple of concepts which we need to revise. One of them is from grade 11th. Let's see if you remember these formulas from your sequence and series chart. So do you recall summation r equal to 1 to n of r? If you recall, the formula is n into n plus 1 by 2. Do you recall summation r square? The formula is n into n plus 1 into 2n plus 1 by 6. Do you recall summation r cube? It is n square into n plus 1 the whole square by 4. If you're wondering what are these formulas doing in ITF, there are a couple of sums where we'll be using them. So you better be prepared for them. Further, students, another concept. Now, for that, I'm sure you already know the formula. Do you recall tan inverse x minus tan inverse y formula, which is tan inverse x minus y upon 1 plus xy. In this particular formula, students, there's one application which we need to discuss before we proceed. So let's take this example. Let's say if I ask you to simplify tan inverse 1 by 7. There's a very special approach that we are going to take to simplify tan inverse 1 by 7, and we'll express it as either sum or difference of two tan inverse terms. I'll tell you how will we do that. In this formula of tan inverse x minus tan inverse y, do you understand the answer in the denominator as this number 1 plus x into y? So what I'll do is I'll split this 7 in the denominator as 1 plus 6. Now, students, we know that 6 can be written as product of two consecutive terms. That is 3 into 2. Students, in the numerator, we have 1. Do you understand that 1 can be written as difference of 3 and 2? If you understand what I'm trying to do is I'm trying to create this. If you compare x is 3, y is 2, so the answer to this is tan inverse 3 minus tan inverse 2. So this is one operation of ITF which you need to know for 1 or 2 sums. This is going to help us in the questions. So you can note this down, students, learn all the formulas, and then you continue with the video. So let us begin. We'll take the first question. The students will take the next question, question number 2. In this, students, we have 2 tan inverse x plus 3 cot inverse x. Now, 3 cot inverse x, students, can be written as 2 cot inverse x plus 1 cot inverse x. We know that tan inverse plus cot inverse is pi by 2, students. I'm trying to use that. We can take 2 common from here. When you take 2 common in the bracket, we'll get tan inverse plus cot inverse, which is pi by 2. So 2 into pi by 2, students, will be pi. So we get a plus pi by 2 is less than pi plus cot inverse x is less than e. Now, here, students, we have to solve this. I hope you know linear inequalities. We have to get rid of this pi. And for that, I'll subtract pi from each term. Now, pi by 2 minus pi is minus pi by 2. Less than cot inverse x and less than b minus pi. Once we get this, students, now you have to just compare this with the range of cot inverse. I hope you already know that the range of cot inverse is 0 to pi. Once you know the, students, that the range is from 0 to pi, you have to understand that over here, a minus pi by 2 is 0, which means a is pi by 2. b minus pi is pi, so b is 2 pi. So that is the answer. A is pi by 2 and b is 2 pi. Let's proceed, students. In the third question, where we have sine of cos inverse x equal to cos of sine inverse x, students, I hope you know the triangle method. We will be using the triangle method for these questions. So over here, sine of cos inverse x, students, let's say it is some angle theta. If we say cos inverse x, I'm checking all the options, by the way. So cos inverse x is theta. So cos theta is x, which is x by 1. Cos theta is x by 1, so this is x, this is 1 by Pythagoras. We'll get this as root of 1 minus x squared. From here, students, we'll get that sine theta is root 1 minus x squared upon 1, and therefore the LHS has this answer, the root 1 minus x squared. You do the same thing, students, for the right hand side. You'll figure out that is also root of 1 minus x squared, and therefore we can say first option is true. If not, then you have to keep checking till the time you get it true. Another way of looking at the, students, is you can just take a random example. That random example can be any number. Let's say x is half, for example. If x is half, students, cos inverse half is 60 degree or pi by 3. And sine of 60, students, is root 3 by 2. So the LHS is root 3 by 2. RHS, you take x as half. Sine inverse half, students, is again 30 degree. And cos 30 is again root 3 by 2. But students, examples, it depends which number you take. If you take a good random number like half or something, it's okay. If you take a very trivial number like 1 or 0, you might get the answer wrong at times. So just be careful with that. Or else just take the normal triangle method approach. Next, students, we'll move to the question number 46. They're saying domain of this function is a comma b. We have to find a plus b. Now, students, what do we know about cos inverse? We know that we have this 3x inside cos inverse, and we know that this 3x should be greater than equal to -1 and lesser than equal to 1. That is the domain of cos inverse. You divide by 3 students, we get -1 by 3 less than equal to x less than equal to 1 by 3. So students, when you compare, this is the domain, when you compare a is -1 by 3 and b is 1 by 3. And a plus b then is going to be 0. Just in case if you're wondering why do we have the square root, why do we have the plus 5 by 4 and everything, you have to understand, students, that is just to validate the question. We can check whether the function is defined for all these values of x. When x will be between -1 by 3 and 1 by 3, we know that the range of cos inverse is from 0 to pi. The minimum value is 0 here, students. 0 plus pi by 4 is pi by 4, and we get root pi by 4, which is acceptable. Negative inside root is not acceptable. Everything else is acceptable. And therefore, students, you have to understand that here the range does not have a role to play. Your focus is only on domain. If you write the domain part, it's sufficient. The answer is 0. Range is only to check whether we can solve this out. Further, students, we'll move to question number 53. So it is given that cos inverse x by a minus cos inverse y by b plus sin inverse is equal to pi by 3, and sin inverse x by a plus sin inverse y by b is equal to 2 pi by 3. Students, we know that cos inverse and sin inverse have this property. Cos inverse plus sin inverse is pi by 2. So what I'll do is I'll just add these equations. When I say add these equations, I'm adding this with this. When we do that, students, cos inverse x by a plus sin inverse x by a will be pi by 2. I'll directly write it as pi by 2. You can show the steps when you write the answers. This is minus cos inverse y by b plus sin inverse y by b. And that is pi by 3 plus 2 pi by 3, which is 3 pi by 3, which is pi. Students, we know that pi by 2 minus cos inverse y by b is sin inverse y by b. So this is now sin inverse y by b plus sin inverse y by b equal to pi. So students, this is now double of sin inverse y by b, which means sin inverse y by b is pi by 2. So y by b, when you transfer sin inverse on the other side, it will be sin of pi by 2. From here, students, we get that y by b is equal to 1. You substitute this in any one equation, students, first or second. I'm substituting it in second. So we have sin inverse of x by a plus sin inverse 1 is pi by 2. And that is equal to 2 pi by 3. So now, students, we have sin inverse x by a. You transfer pi by 2 on the other side. We have 2 pi by 3 minus pi by 2. Take LCM. It's basically 120 minus 90, which is 30. So you'll get pi by 6 after taking LCM. You transfer sin inverse on the other side, students, it's sin of pi by 6. Sin of 30 is half. We get x by a is half. You substitute everything in this equation, students, which we need to find the value of. So we have 4 of x squared by a squared. So that is 4 of half square plus 1 square. The answer, students, is 2. Next, students, let us take this question number 87. Question 87 is that question where we will have to use that special rule of tan. See, very smartly in the first bracket, to give you all a hint, they have written it as 1 upon 1 plus 1 into 2. They could have directly written it as 1 by 3, but they did not do that because they wanted you to understand. You have to use that rule which we just discussed in the very beginning. So we'll be using that trick over here. In the numerator, students, the 1 can be written as 2 minus 1. It is difference of 2 and 1, and this is 1 plus 1 into 2. In the next number, we have 1 by 7 students. So that 7 students is basically 1 plus 6. We can write the 7 as 1 plus 6, and 6 is basically 3 into 2. And the numerator will be 3 minus 2. You keep doing the students till the last one. The last number, students, is 111. In the denominator, students, we will have 1 plus 110, which is 11 into 10. In the numerator, students, we'll have 11 minus 10. So here, students, we have these tan inverse terms, and they are saying this is the value of s. We'll have to keep solving this, students. This is now tan inverse x minus y upon 1 plus xy. So we'll use this formula that tan inverse x minus y upon 1 plus xy is tan inverse x minus tan inverse y. So this is tan inverse of 2 minus tan inverse of 1. Next, students, we have tan inverse of 3 minus tan inverse of 2. You keep doing this, students, till the last one, which is tan inverse of 11 minus tan inverse of 10. And that is S. Now, what will happen is, students, all these terms are going to get cancelled. The only terms, remember, in these kind of questions, the only terms that are left are the first and the last. When I say first and the last term, I basically mean the number, the term with the least number and the term with the highest number. So we'll be left with tan inverse 11 minus tan inverse 1. And that is the value of S. I'm sure you must be tempted to write tan inverse 1 as pi by 4. Don't do that because we are not yet done. You have to find tan S. I'll use the property tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus x into y. So from here, students, we get s is tan inverse. You'll get 10 by 12, which is 5 by 6. When you transfer tan inverse on the other side, tan of s, students, is 5 by 6. With that, we complete this question as well. So students, the next and the last question that we have for ITF, question number 101. Here, students, we have to find the value of this expression. I'm sure after looking at this expression, you're wondering what the hell is this, but don't worry, I'll make it easy for you. So first, students, let us start from the innermost bracket. I'll keep copying the other terms. We have summation n is equal to 1 to 25 of cot inverse. You keep copying this. 1 plus. I want you all to understand what is this summation 2k. So here we are going to use that sequence and series concept, students. This 2k, you ignore the 2, like you take it outside. When you see summation k, students, where k is from 1 to n, that is exactly like summation r, the formula which I told you. So summation of r, we know that is n into n plus 1 by 2. Now you write r or you write k, it doesn't make a difference here. It's k, so I'll make it k. When you take 2 on the other side, cross multiply, we can do that with summation. We can directly take it inside. Summation 2k, students, is n into n plus 1. So here, students, we have n into n plus 1. Now see, in ITF, we don't have any formula for cot inverse, but we have some formulas for tan inverse. So I'll have to convert this to tan inverse. So I'll write it as tan inverse. We'll take the reciprocal. So we have 1 upon 1 plus n into n plus 1. Now, students, this is similar to the previous question. You look at n and n plus 1. What is the difference of n and n plus 1? Do you observe, students, the difference of n and n plus 1 is 1. So in the numerator, students, tan inverse, I'll write it as n plus 1 minus n. I'm basically adding n and subtracting it. This is 1 plus n into n plus 1. This now is clearly the tan inverse formula, students. So we have summation of n is equal to 1 to 25 of tan inverse of n plus 1 minus tan inverse of n. So now, students, will substitute summation. I hope you understand what is summation. Summation means addition. So students, when you substitute n as 1, students, we will get tan inverse 2 minus tan inverse 1. When you substitute n as 2, students, we get tan inverse 3 minus tan inverse 2. You keep doing this, students. The last term that we have is 25. So we'll get tan inverse 25 plus 1 is 26 minus tan inverse 25. As I told you in the previous sum, students, in these questions, the first and the last term, which means the term with the least number and the highest number, will be left. Everything else gets cancelled. So students will be left with tan inverse 26 minus tan inverse 1. Don't convert it to pi by 4. We'll use the tan inverse formula. Tan inverse x minus tan inverse y is tan inverse 26 minus 1 upon 1 plus 26. Which gives us tan inverse 25 by 27. But because we have cot outside, students will convert tan inverse to cot inverse by taking reciprocal. Our answer is 27 by 25. I hope, students, you understood these questions. We are done with this particular session for ITF. In the next session, I'll see you for matrices and determinants. Thank you.